So in this problem, we need to determine the coordinates of the focus and the length of the lattice rectum of the parabola y squared equals to 4ax if it passes through the point 3, negative 2. Let us begin. Now here we have the equation of the parabola, which is a standard form for this particular parabola. This is a right-facing parabola. The coordinates of the vertex of this parabola is going to be at the origin 0, 0. Now, the coordinates of the focus of this parabola is going to be at a, 0, and the length of the lattice rectum of the parabola, that's given by 4 absolute value of 4 times a. Now, it's given here that the parabola passes through the point 3, negative 2. So this suggests that the point 3, negative 2 is going to satisfy the equation of the parabola. All we have to do is replace the value of x with 3 and the value of y with negative 2 into the equation of the parabola. So we get y squared equals to 4ax. So this will be equivalent to negative 2 squared equals to 4 times a times x. So here we have negative 2 squared, that's 4. 4 will be equals to 4 times a times 3. So 4 and 4 will get factored out. That gives us the value of a as 1 over 3. Now that means we can now define the coordinates of the focus. So the coordinates of the focus of the parabola is going to be 1/3, 0, and the length of the lattice rectum of the parabola, that's going to be absolute value of 4 over 3, or simply 4 over 3 units.